Yeah, good evening all. Now I am going to explain about second order system. Okay, in case of time response analysis. Okay, the open loop transfer function of a second order system is omega n square by s into s plus zeta omega n. Here C of s is the output, R of s is the reference input, right? Okay, then transfer function C of s by R of s is equals to omega n square by s square plus 2 zeta omega ns plus omega n square. Okay, here omega n is the natural frequency where zeta is damping ratio. Okay, from this equation denominator already we know that 1 plus g of s into h of s, right? From this transfer function, that is g of s by 1 plus g of s into h of s. That means the characteristic equation of this equation is s square plus 2 zeta omega ns plus omega n square is equals to 0. Okay, then the roots of this characteristic equation will be s is equals to, see here, minus b, right? That value is minus zeta omega n plus or minus under root b square minus 1, right? Ax square plus bx plus c form, right? Okay, if I simplify the roots, minus zeta into omega n plus or minus j into omega n into under root 1 minus zeta square are the roots of the second order system equation. Okay, from this equation zeta into omega n value can be written as minus alpha, right? That means here alpha value is zeta into omega n plus or minus j into omega n into under root 1 minus zeta square value can be written as omega suffix d, where omega suffix d is damped frequency of oscillations. Okay, whereas alpha is damping factor or damping coefficient. Okay, from this equation 1 by alpha is nothing but a time constant. Okay, then time constant formula is time constant is equals to 1 by alpha, that is equals to 1 by zeta into omega n. Okay, then the magnitude of roots will be, already we know that these are the roots of the characteristic equation, right? Then the roots will be s is equals to under root minus alpha square plus or minus omega d whole square. Okay, now see here, based upon this zeta value, see here from this equation, based upon this zeta value, okay, the system are again classified into 4 types. One is undamped system, another one is underdamped system, okay, critically damped system and overdamped system. Now see here, first of all, zeta is equals to 0. See here, substitute here zeta value as 0. When zeta value is 0, what is this real part is 0, right? This value is also 0, then you will get only plus or minus j into omega n. Okay, when zeta is equals to 0, the roots are plus or minus j into omega n. That means the roots will be located on imaginary axis. That means all roots are imaginary. Okay, this system is undamped system. When zeta is equals to 0, the given system is a undamped system. Okay, for this undamped system, the roots are placed on imaginary axis. Okay, this is the waveform in case of zeta is equals to 0. This is the response of a output. Okay, that is about undamped system. After that, next one is underdamped system. In case of underdamped system, zeta value is varies between 0 to 1. Now see here, from this equation, zeta value is varies between 0 to 1, right? That means this value is something, one value, assume 0.1, that means minus 0.1 omega n plus or minus j into 0.1 under root 1 minus 0.1 whole square, means that means some value. That means you will get roots as minus some constant into omega n plus or minus j into omega n into some constant. That means you will get roots like this only, minus zeta into omega n plus or minus j into omega n. That means same as real part plus or minus j into imaginary part. That means when in case of underdamped system, this is a practical system. Underdamped system is a practical system. Okay, roots are complex conjugate. Okay, the roots are placed on left half of s plane only, right? That means minus 1, here it is minus, for example, assume minus 1 plus 1j, here minus 1, here minus 1j, right? Okay, this is the representation of poles. Okay, then the response of this underdamped system will be like this. Okay, next, critically damped system, that is zeta is equals to 1. Now substitute here zeta is equals to 1, right? You will get minus omega n plus or minus j into omega n into zeta value. 1 minus 1 square is nothing but 0, right? That means imaginary part value will be 0. That means 2 roots values will be minus omega n. That means when the system is critically damped, the roots will be 2 roots are minus omega n will be only. That means this is the location. That means roots are real and equal. That means minus omega n, one root, another root is also minus omega n, right? That means when zeta is equals to 1, the roots are real and equal. Okay, this is the response, output response, C of t output response in case of critically damped system. Next, over damped system, zeta value is greater than 1, then the given system is a over damped system. Now see here, assume here zeta value is greater than 1. Okay, this value is minus omega n plus or minus j into omega n into 1 minus, here more than 1 value, right? Zeta value, that means 1 minus minus 1.2 whole square, you will get minus 0.2 square. Again here minus 1 whole square you will get as minus j square. That means again j will come outside, j into j square. This value is again minus 1, right? That means the polarities will be minus 2 plus, right? Then the polarities will, then the given equation is minus zeta omega n minus 2 plus, right? Here omega n into under root zeta square minus 1. Why? Because this value is higher, right? Okay, that means here no complex conjugate, right? That means here roots are real and unequal. Under overdamped system, roots are real and unequal. Now see here, if we compare with this response, zeta is equals to 1 is having faster response. When zeta is increases, the response of a system is slow. Okay, the response of a system is low. Okay, that is the waveform when zeta is greater than 1. Okay, after that, when a steady state input is given to the second order system, okay, here directly I am writing the equation. The output C of t value will be C of t is equals to 1 minus e power minus zeta omega n into t divided by under root 1 minus zeta square into sine of omega dt plus phi. Okay, after that here cos pi is equals to zeta. Okay, cos pi is equals to zeta, then phi is equals to cos inverse zeta. Then if we know cos pi, then we can easily calculate sin phi, right? Then sin phi is equals to under root 1 minus zeta square. Okay, then tan phi value is, here it is phi, tan phi value is under root 1 minus zeta square by zeta. Okay, this is the waveformatical representation. That means if just observe here alpha is constant, right? This is minus alpha, j omega d, right? Here the location of poles, this is plus j omega d. Okay, here it is minus j omega t. Okay, this is imaginary axis, this is real axis, right? If we consider plus alpha also, this is plus alpha, no problem. Okay, now see here, when zeta is equals to 0, roots are imaginary, right? Next, this is the region from 0 less than zeta less than 1, right? Roots are real, that means complex conjugate. Real and imaginary means, right? Complex conjugate, that is minus 0.5 plus j something value like that. Okay, next, this is zeta is equals to 1. Next again 0 less than zeta less than 1. Again here zeta is equals to 0. In this way we will get a waveform. Okay, from this equation if I draw the, here it is a phi value, right? Here I am indicating each and every value. This is alpha, here it is omega d, right? This is phi, cos pi is, right? Cos pi is equals to, already we know zeta, right? Now see here, based upon all these values, see here, this is the position of omega n, natural frequency. Okay, remember these, all these points, omega d axis, this is alpha axis, this is omega n, this is phi, right? Now see here, now from this waveform we will make some conclusions. Okay, Okay, this in this case omega n is constant. This is omega n is constant, and zeta is varied from minus infinity to plus infinity. We will get the graph like this. Okay, first one is constant zeta locus, right? In case of constant zeta, right, then phi value should be constant. To maintain this zeta as constant, phi value is constant, means this angle should be constant. When this angle is constant, this omega n value is increases. That means in case of constant zeta locus, only omega n value is increases. Okay, that is about constant zeta locus. Next case, constant alpha locus, right? Okay, this is the point of alpha, right? Okay, that means we need to maintain this value as constant. Okay, if we maintain this value as constant, which parameter is increases? Okay, this is increases, right? That means omega d is increases indirectly. Okay, when alpha is constant, omega d value is increases. Okay, when omega d value is increases means indirectly omega n value is increases, but zeta value is reduces. Okay, zeta value is reduces. Next, constant, why this zeta value is reduces? Already we know that omega d is equals to omega n into 1 minus zeta square, right? When this value is low, then only this value is increases, right? That means when omega d value is high, zeta value should be less. You remember in this way. Next, constant omega d locus, right? Here omega d is constant, right? Okay, when omega d is constant means like this, omega d is constant. That means omega n waveform is like this, right? Then omega n value is increases. Okay, omega n value is increases like this. Zeta is also increases in case of constant omega n axis. Okay, next, these are the time domain specifications. That means already we know that for a practical system is a underdamped system, right? This is the waveform, right? Underdamped system. Okay, for this system, here it is a delay time. Okay, next rise time, next peak time. Okay, we can calculate all those parameters. Delay time is nothing but it is the response to reach from 10% to 50% or 0% to 50% is known as delay time. Okay, mathematically the delay time formula will be 1 plus 0.7 zeta by omega n. Next, rise time. Okay, it is the time taken to reach the response from either 10% to 90% or 10 to 95%. Also rise time, that rise time is equals to pi minus phi by omega t. Okay, next, peak time. Peak time formula, maximum time, that is nothing but pi by omega d. Okay, next, time period of damped oscillations will be 2 times of peak time, that is 2 into tp. Okay, next, mp or peak overshoot. Okay, peak overshoot formula will be e power minus pi zeta by 1 minus zeta square. Okay, for example, here substitute zeta is equals to 0, you will get e power minus 0, right? If I substitute zeta is equals to 0, you will get 0, e power minus 0, e power 0 value will be 1, right? That means mp value is 1, means 100%, right? When zeta is equals to 1, this denominator value is 0, right? You will get e power minus infinity, that value will be 1 by e power infinity, that is 1 by infinite, that value will be 0. That means the conclusion is when zeta value is 0, mp value is 100%. I am talking about only mp. mp is different, percentage mp is different. Next, when zeta is equals to 1, mp value is 0%. That means when zeta value is low, mp value is high. When mp value is high, zeta value is low. Okay, now see here, if we solve one problem on this concept, see here, g of s is equals to k by s into s plus 2. Okay, if k value is increases to infinite, then the damping ratio of system, okay, k value is increases to infinite, right? Okay, now see here, what is the characteristic equation? 1 plus g of s into h of s, right? Then the characteristic equation you will get 1 plus g of s into h of s is equals to 0. Okay, then okay, now see here 1 plus k by s into s plus 2, right? You can take separate paper, right? What is the g of s value? G of s is equals to k by s into s plus 2, right? Okay, then characteristic equation 1 plus g of s into h of s is equals to 0, that is 1 plus k by s into s plus 2, right? That is s square is equals to 0, s square plus 2s plus k is equals to 0, right? Okay, what is given? G of s is equals to k by s into s plus 2. If k value is increases to infinite, then damping ratio of system. He is asking damping ratio is nothing but zeta, right? We need to calculate zeta. Compare with standard equation, that is s square plus 2 zeta omega n s plus omega n square is equals to 0, right? From this standard equation, if I compare, omega n square is equals to k, right? Then omega n is equals to under root k. Next, from this standard equation, 2 zeta omega n is equals to 2, right? 2 and 2 will be cancelled, right? Then zeta is equals to 1 by omega n, right? That is already we know omega n value, right? Omega n value is 1 by root k. What is given? The value of k is increases to infinite. That means here k value is infinite, right? Substitute that value here, 1 by root infinite, 1 by infinite value will be 0 is the answer. Okay, now see here, what is the first option? 0. Then first option is the correct. Next, transfer function is equals to 12 by s square plus 12s plus 12, right? Then the given system is, okay, overdamped, underdamped, critically damped and undamped, right? You can compare with the standard equation again, g of s by 1 plus g of s into h of s, right? That means s square plus 12s plus 12 is equals to 0. From that standard equation, omega n square is equals to 12, omega n is equals to root 12 radians, right, per second. Then 2 zeta omega n is equals to 12, right? That is 6. Zeta into omega n is equals to 6. Okay, then zeta is equals to 6 by omega n. Omega n value will be root 12, right? Root 12 can be written as 4 3s are, right? That means zeta is equals to 6 by 4 3s are 12. That means root 4 value will be 2 divided by root 3. 2 3s are 3 by root 3 is nothing but zeta value will be root 3. Okay, that means 1.732, right? That is a overdamped system. In this way we can solve the problems. Okay, thank you all.